For over a decade, the world's largest nuclear power plant has lain eerily dormant. A chain of mishaps, both natural and man-made, have delayed its reopening. Yet many locals are clamoring for its return. So why did Kashiwazaki Kariwa in Japan close in the first place? What's keeping it shut? And could a previously undetected fault line under the sea condemn it to being abandoned forever? Join us today as we ask why the world's largest nuclear power plant was shut down. Kashiwazaki Kariwa Nuclear Power Plant straddles two towns in the west of Niigata Prefecture named, you guessed it, Kashiwazaki and Kariwa. It's about 135 miles northwest of Tokyo on the Sea of Japan coast. Work on the first reactor began in 1980, and in 1985 the first reactor came online. It was followed by another 6 reactors, the last of which came online in 1997. The plant was, and still is, the largest nuclear power generating station in the world by net electrical power rating. That means it's capable of pumping out 8,212 megawatts, which breaks down as 5 chunks of 1,100 megawatts from 5 conventional reactors and 1,356 megawatts from each of the final 2 reactors installed, which are ABWR or Advanced Boiling Water Reactors, the first such reactors commercially deployed anywhere on Earth. In fact, in theory at least, Kashiwazaki Kariwa is the 4th largest electricity generating plant of any kind on Earth, behind 3 massive hydroelectric behemoths: the Itaipu on the Brazil-Paraguay border, the famous Three Gorges Dam in China, and the Guri Dam in Venezuela. For many years, Kashiwazaki Kariwa dutifully supplied the local grid with clean nuclear energy, with only a few minor mishaps to report. A hazy slip-up in the early 2000s led to some of the reactors being temporarily taken offline, but authorities chose not to pursue an investigation and allowed the plant's operator, TEPCO, the Tokyo Electric Power Company, to resolve the matter internally. In 2007, the 6.6 magnitude Chuetsu offshore earthquake forced TEPCO to take all 7 reactors offline, a colossal setback necessitating the use of natural gas plants just to keep power supplied to the grid. This natural calamity, which had a recorded epicenter just 12 miles away from Kashiwazaki Kariwa, shook the plant beyond expected tolerances set out in the original design, leading to electrical fires and radiation leaks, albeit leaks well within safe tolerances. And even though the reactors themselves were left unscathed, a 21-month shutdown of the site ensued. Kashiwazaki Kariwa's shiny new Unit 7 reactor was brought back online first, following earthquake-focused upgrades on May 19, 2009, followed by older units 1, 5 and 6. The remaining units, 2, 3 and 4, were still offline when the next natural disaster not only derailed operations, but made grim headlines around the world. The March 2011 earthquake and resulting tsunami caused devastation and meltdown at another Japanese coastal nuclear facility, Fukushima Daiichi. As it happens, neither the quake nor tsunami directly affected operations at Kashiwazaki Kariwa, but in the ensuing global climate of fear over the potential fallout from Fukushima, all 7 reactors were again taken offline so additional safety measures could be implemented. These additional safety measures, which set TEPCO back an estimated 1.3 trillion yen and counting, were designed with the Fukushima nightmare scenario in mind. At Fukushima, the textbook response to a big emergency was for the reactors to immediately shut down, with cooling water circulated to keep the fuel rods stable. But the massive unforeseen tsunami interrupted this process, inundating the lower levels of the reactor building with seawater. This flooded Fukushima's diesel generators, so its cooling systems had no power. That's how the reactor melted down, spewing radiation into the local atmosphere. Worse, the overheating fuel rods split the very water molecules in the surrounding steam, creating violent hydrogen explosions and still further damage. Engineers at Kashiwazaki Kariwa sought to avoid that scenario by raising its on-site seawall to 15 meters in height. This is despite evidence that a local tsunami could only ever reach about 6.8 meters above sea level. Such conservatism would be repeated across a raft of new safety measures. But what if even this gigantic wall was breached? The buildings themselves were expensively barricaded in waterproof covers to prevent seawater entering the plant buildings, even through vents or windows. Local drainage systems were expanded and reinforced just to be sure. In order to avoid what happened at Fukushima, when a Japanese self-defense force helicopter was forced into service, dumping seawater on the plant's ravaged reactors, a new 20k-ton dedicated firefighting reservoir was constructed near the Kashiwazaki Kariwa plant, sited at 45 meters above sea level. In addition, 42 water cannon trucks are now permanently stationed at Kashiwazaki Kariwa, with an extra failsafe of special steam-driven pumps that could, if needed, deliver water powered only by vapor from the hot reactors themselves. Maintaining power at all costs is critical, as the Fukushima disaster illustrated. So Kashiwazaki Kariwa engineers have also installed 4 sets of mobile gas-fired generators and switchboards on high ground, and a fleet of 20 mobile generator cars as a backup. All that, plus a new design of filter vent that prevents 99.9% of all radioactive particles escaping, a beefed-up emergency workforce numbering 850 people instead of 324, and regular intense drills. So you'd think they're good to switch on by now, right? Wrong. Despite the vast sums invested by TEPCO on site, the most optimistic current estimate has Unit 7 coming online in late 22, with the other reactors hopefully following one by one until they're all online by about the year 2028. Why? Public trust in Japan and around the world was shaken by Fukushima. Nuclear facilities, especially plants near fault lines, need to be 100% safe and seen to be 100% safe. And despite the vast new seawalls and expensive new infrastructure installed at Kashiwazaki Kariwa, questions have been raised around issues of trust in the leadership. For instance, there was the 2002 scandal involving falsification of crucial data. Staff, anxious that a forthcoming inspection might cause closure, carried out what TEPCO itself has since called dishonest acts by manipulating steam isolation valves to mislead auditors into thinking the leak rate on a valve was lower than in reality. It's also come to light that in 1995, a diesel backup generator at Unit 3 went down, but this was not reported when it should have been. An on-site thermal output reading, a critical safety metric, was exceeded on 5 occasions between 1991 and 1998, but workers entered inaccurate figures in the log. We apologize from the bottom of our heart for causing anxiety to the public and local residents, grovelled TEPCO Vice President Katsutoshi Chikudati at the time. Worse, in January of 2021, it came to light that the site had inadequate provision of protection against terrorism and inadequate protection in place for its nuclear materials at multiple locations across the dormant plant from 2018 onward. It also emerged that unauthorized individuals had somehow breached the central control room using an employee ID card. In addition, an intruder detection system had not been functioning and had remained unreported for an unspecified period of time. These administrative slip-ups are still causing TEPCO headaches, as are serious concerns from the 2007 earthquake. During that quake, whose fault line now seems to run directly under the Kashiwazaki Kariwa site, some 400 drums containing low-level nuclear waste were knocked over. 40 lost their lids. TEPCO was roundly criticized for reporting errors late, and because radiation sensors around the site, designed to give locals an early warning of trouble, were offline in the aftermath of 2007, causing confusion and rousing suspicion. So you might think locals would be happy to see the back of the Kashiwazaki Kariwa plant, but it's a bit more complicated than that. Despite the fact that in a recent referendum, locals narrowly, by 53%, defeated plans by TEPCO to move to mixed oxide fuel, broadly speaking, people in the area like the plant. It employs 6,300 people, and many families depend on it to pay the bills. It might be noisy, dangerous infrastructure in their backyard, but the government pays handsome subsidies of over 4.7 billion yen to soften the blow. When you factor in taxes, the overall local boost to revenue from the plant is closer to 11 billion yen. There's competition for that money too. In November of 2020, the mayors of Onagawa and Ishinomaki in Miyagi Prefecture approved the restart of their local nuclear power station, the first such facility to be reopened since Fukushima. In the town of Kashiwazaki, a dwindling population, which shrunk dramatically from 90,000 in 2010 to 81,000 last year, is tired of unemployment and boarded up shops. So they recently re-elected Mayor Sakurai Masahiro, who ran on a platform of reopening the plant. He won in a landslide. So Kashiwazaki Kariwa was shut down after damage following a 2007 earthquake, then kept closed amid a climate of fear following the Fukushima disaster. It's still closed, shrouded in awkward questions over the trustworthiness of its management. It remains to be seen whether keen locals and a Japanese government, scrabbling to meet its own Kyoto Protocol targets, will summon the courage to switch the lights on again. What do you think? Is nuclear energy worth the risk, even in earthquake-prone coastal spots? Let us know in the comments. And don't forget to subscribe for more power-mad tech content.